Hello everyone, welcome back to my channel. Today we have an exciting topic to dive into, that is DragGANs, a fascinating approach to generative adversarial networks or GANs. We will walk through the detailed paper and explore its building block and even demonstrate how you can run DragGANs in Kaggle or in Colab or even in your local machine. So let's not waste any time and get started. What are DragGANs? Comparing to other GAN models, DragGAN allow us to drag the content of any GAN generated images. User need to click on few handle points that are red points and the target points, that is blue points, on the image. For every iteration, DragGAN model will change the latent space by tracking the points on every new generated image. It will move the handle points closer to the target points. When the handle points reaches target points, model stops generating images. Like here you can see the red points are moving closer to the blue points. And DragGANs has also one more feature where we can draw a mask on a specific region of the images, like the brighter area, and the model will make changes only on the highlighted latent space, keeping the rest of the unmasked image unchanged. This will allow us have it to control of what the GANs are generating. That is what DragGANs are. Before we dive into technical details of DragGANs, first let's recall what GANs are. We can consider GANs as two components. One is generator and the other as discriminator. We can think of generator as an artist where it will try to create fake currencies or images, and discriminator as detective where it will try to distinguish between fake and real currencies or an image. As based on discriminator feedback, generator or artist learn to create new currencies until discriminator cannot distinguish between real or fake currencies or an image. This is how the general training of GAN happens. Now let's understand this in technical terms. GANs are made up of two neural network models where we at initial stages we pass randomly sample noise as input vector. In most cases we will sample from a Gaussian distribution. We take that noise vector as input into neural network, follows through bunch of convolution layer, and at the end we have an image. This image is fed into second neural network, that is discriminator. It has one job, to decide as it is real or fake by calculating the loss using real image from dataset and the image which is generated by a generator. Using this loss we can back propagate through a training loss through this discriminator network in order to make it better, as both we know that discriminator and the generator are neural networks, so they are fully differentiable neural networks. So if we stick these neural networks back to back, we can back propagate learning signal through the entire model of pipeline. In this way, we can update same signal loss function. We can update both discriminator and generator network until they both become good at their job. So in this process, the most important trick is the pipeline to make sure both these networks are well balanced in training so that no one will get an upper hand. If we manage to do so and train it for a long time, then eventually we have a generator where it has been learning from the feedback of discriminator network and can manage to generate images that look similar to the dataset that we are training for. Having the basic understanding of how GAN works, now let's go through the DragGAN paper and understand it. In DragGAN paper, as they have mentioned that they are using below methods. One is StyleGANs, point-based manipulation, and motion supervision. To understand StyleGANs, first we need to understand progressive growing. Progressive growing of GANs is also implemented by NVIDIA, same as StyleGANs. Progressive growing of StyleGANs is nothing but the GAN starts with the low resolution image, like here it is 4x4 image. First it will try to stabilize the 4x4 image, and after that it will increase the resolution of the image size. Meanwhile, it will also try to stabilize the higher resolution image. While in the process of training, at the end it will have an high resolution image. This is what progressive growing of GAN does. Now in StyleGAN, traditionally what happens is that you take a generator architecture and get randomly noise samples as input. You feed that noise sample to the whole bunch of upsampling and convolution layers until you get an image. What the StyleGAN generator does is slightly different. First, it has a mapping network, and this mapping network take the noise vector Z and transform it into different vector called W. The important point is W vector does not have to be Gaussian. The distribution of W can be anything as generator want to be, so that the actual generator architecture doesn't start with a random sample noise. It starts from a constant vector, and this constant vector is optimized during training. Finally, the output of this mapping layer W is plugged into multiple layers of generative architecture using a blending layer called add-in. And during training, we also add noise. You might be confusing that what is the use of mapping. Whereas in normal GANs, Gaussian distribution is uniform, where generator needs to manipulate from uniform distribution. Whereas in mapping network, it helps to sample from the uniform distribution, then wrap that distribution in such a way that you can have generator. For example, when there are no actual images, and the idea is that the wrapping of space is already done by the mapping network. So our W vector is already in good shape. So our actual generator the vector and turn it into an image as a much simple job. So this is the StyleGAN generator architecture. Like, generator start from constant and use mapping networks, and it also use progressive growing of layers. Now, after having an overview of StyleGANs and progressive growing of GANs, now let's understand DragGANs and how they have used StyleGANs in detail. In DragGANs, they have used StyleGANs too. That is the advanced version of StyleGAN, which is also invented by NVIDIA. As in normal GANs, it starts from randomly sample noise. Here in StyleGAN 2, it starts from feature space. We also call it as latent code, a space that will basically represent the pool of images you can generate. If you select a precise point in the space, it will have an attached value to it, and by feeding those value to our generator, we will get an image out of it. It is like manipulating the latent code. We will get some similar images. This space is linked with the image space we want to generate. Closer point in the space represent similar images. So DragGAN has two steps to repeat until the image is at final destination. For each new target points, the model first step is to take the current image and move its representations. That is to manipulate the latent space such that handle points are moved to target points in this feature map towards the right to generate and the second image, and so on. So once we have understood the theoretical part of DragGANs, now let's dive into the code. So I will be sharing this Kaggle collab. I will be sharing this Kaggle notebook link in the description. You can directly access this notebook by the link in the description. Either if you are in Colab or in your local machine, you just need to run the same cell commands in your local and even Colab machines as well. First thing you need to do is you need to clone the GitHub repository where as link is mentioned over here. After cloning the repositories, you need to download all the packages using this pip install requirement.txt command. After running those command, and you can run from import the main function from the Gradio app, and after installing this everything, and if you run this cell, you will directly get those where URL to run this is in a cell, or you will also get an public URL where you can run this, or also you can directly even manipulate over here as well. If you want to change anything over here, first you need to click on target points, and it will load it by itself. And once this target point is been loaded, and you can click on the like handle point has been done, and click on the target points, and when you click on drag it, it will start by itself. Make sure that, but it is very slow. It will take time to reach the handle points to the target points. Elsewhere, if you have some GPU, you can directly use that. And thank you very much. Thank you very much for watching this video. Like the video and subscribe to the channel. And